Mines are getting deeper and deeper, and that's raising new safety issues, obviously increasing costs.
We put together a tough challenge, a tough question, but a serious question, one that's facing us.
It was just really laid as a challenge of having to increase the productivity of a deep mine to make it cost effective, and then leaving it to the students to look for different ways to address that challenge.
Now, these finalists have the opportunity to pitch their ideas to a group of Ontario Mining's top executives. Who will impress the dragons and walk away with the top prize? Please welcome the Master of Ceremonies, George Flemmerfeld.
Okay, well, it's a moment of truth for the finalists. They're about to face a panel of top mining executives, and we'll try to convince them that their idea is the best, Dragon's Den style. For now, I'm excited to introduce you to the first finalist from Laurentian. Please put your hands together for Shiv Sharma, who came up with a lasting impact.
Hi, my name is Shiv Sharma and I attend the best mining school in the world. Mining as we know it today is unsustainable. We're not making enough changes and we have to make those changes. Number one, we're noticing that our reserve grades are falling in many cases as we keep mining deeper and deeper. And consequently, some of our CapEx and OpEx costs are going up. There's 4 primary reasons why that's happening. Our workplaces are getting more hazardous, we're facing poor ground conditions, and their energy costs are going through the roof. My solution is pretty simple. If you have large rocks and you can't dig a large hole, so let's make the rock smaller and dig a smaller hole. Now I see some smiles in the crowd right now, but I just want you to entertain the idea for a minute. If you use ream boreholes between 12 to 30 inches, depending on what the geotechnical data allows for, and you use the impactors to drop the broken material to the bottom to your conveyor drift, and then you take it to your loading pocket and your skip, you can save a lot of money. Now, how much money could you possibly save? Well, about an 8-fold reduction in your overall haulage cost. My premise was very simple. Decentralized crushing, in my opinion, is better than centralized crushing, simply for the fact that you don't need the big excavations and the auxiliary investment to make it all work. Number 2, the drilling is really cheap. So let's take advantage of it. If you look at what you can achieve a 90% reduction in your overall haulage costs. You're going to make your mine safer by eliminating one of the biggest hazards in the mine, which are underground trucks. The productivity gains that you can achieve comes to about 150% once you adjust for the fact that you can go from 400 tons per shift to 1,000 tons per shift per stope. Your overall savings across the life of mine is about $120 million, which if you annuitize over the life of mine, over the 11-year life of mine, at a 5% discount rate, comes to an increase in the net present value by almost $90 million. I would say that's quite the lasting impact. Thank you.
You said that you've got an 8-inch top size feed and your drilling is cheap. You said that drilling is cheap.
Very cheap, yeah.
How much risk would there be in moving to fewer and larger holes as you proposed?
Well, you would have to do the geotechnical analysis on that one. I couldn't tell you right off the bat. However, there's a difference between ore passes that we use today that are typically 5 to 7 meters in diameter versus what I'm proposing, which might be a 30-inch borehole, which is really nothing compared to what we're talking about.
So with smaller boreholes, with larger chutes, a little bit more room to get on and block them when they do get blocked up. How do you propose to unblock this?
You can typically use compressed air for that one. The more sophisticated way would quite literally be to set up where the closest overcut is to where that hole is and essentially dropping down a reamer bit and just popping it right out.
I noticed when your cost estimates, you used an electric truck. I think it was the Z40 electric truck. Would that cost savings have been the same if it was just a traditional truck?
I basically assumed that it would come down to about the same cost on an ownership level. But the real savings with electric trucks comes with the fact that you no longer need 32 or 33 CMS of air for that individual truck. And I think that's one of the reasons why Glencore wanted to go with the electric truck, is just the savings that you would achieve on the ventilation side of the discussion.
So now we're going to meet the team from Queens, Samuel Grant and James Fortune, and they're going to talk to us about their better built belts.
So mining industry right now is facing two major problems. One is a decrease in the grade of ore and the actual deposits being found at greater and greater depths. So this obviously has a huge negative effect on the NPV of mines, and the simple solution to this would be mine faster. Some areas of focus that we looked at were the equipment fleet and cycle times, and finally settling on reducing cycle times leads us to our idea of constructible conveyor belt systems. So the actual system will be composed of meter-long pieces which are held together using a two-part connection system. The first part being mechanical linkages, and the second part being electrically induced magnets, which actually works as a safety mechanism. And then this design will be set up into stopes and along drifts, and is actually composed of biodegradable rubber, which allows for durability and environmentally friendly disposal. This design idea will allow for a quick setup and takedown while effectively removing an entire leg from the haul cycle and still remaining adaptable to the ever-changing environment in an underground mine.
Pictured here is one of the stope levels given in the case study. So in this example, there's 150 meters between the truck loadout and the stope deposit, which is the average throughout the entire mine. In our study, we wanted to greatly reduce the park timer specifically. And our solution in putting belts in both the main axis drift and the crosscut drifts reduces the park timer to below 1 minute. This reduction represents only 20% of the time taken by LHDs. And with this, we have estimated that 96 trips can be made throughout a day, whereas the current study had only 25 trips throughout one day. Once the stope is completed, the belt will be disassembled on the primary crosscut and then reintroduced into the secondary crosscut.
This project allows for the threefold in production to be used by effectively eliminating an entire leg of the cycle time, and it opens the door for synergies to be made within historic equipment and modern-day mining technology to help redefine the past and really optimize the future of mining. Thank you for your time. I'd like to open the floor to questions.
So the setup, takedown of these belts, how does that impact your overall cycle time?
The assembly of the belt was highlighted as one of our faster innovations. And while it does take more time than just an LHD driving in, that time is saved when the backfill is laid out at the same time and when the secondary crosscuts are filled at the same time that the primary crosscuts are being developed. So only the very first crosscut of a level will get this kind of a cycle reduction. And then as you move through the other crosscuts, you do it at the same time, and it's time neutral.
Why did you choose to sort of bring it to the truck and sort of end your solution at that point, as opposed to rethinking the entire operation?
Within the case study, we were told that the ore pass was looked over for this particular study, and that more work would be needed to reopen that ore pass. Our study minimizes the changes that are needed for the logistics of a mine and helps us to accurately determine what the actual impacts will be. A larger change of a conveyor system through the entire mine would require much more consideration for all these changes.
Okay, thanks, guys. Now, ladies and gentlemen, please welcome the last of our finalists representing Laurentian University. Here are Anthony Ferrugia and Michael Janakaraj.
Hi guys, thank you so much for coming out today to hear us talk about our MINED Innovation Challenge. My name's Anthony.
My name is Michael.
And today we're actually going to be discussing subsurface mining methods and as an advanced in situ bioleaching.
To begin our method, we start off by creating a 10% void space within the stope. This allows us to have enough space when we begin fracturing it later on. After this, we do not require major changes. We chose to keep the same stope size that was already presented so that we can have the lowest capital cost while getting production as quick as possible. After this, we use a fan drilling pattern along the ore body, which we can use the drill holes to set up a self-frag system. The self-frag system is a selective fracturing method. It uses high voltage pulses to fracture the minerals along the grain boundaries. This allows us to expose the minerals to a leachate that we'll use later on in our method. It allows for pre-weakening, which gives us lower processing costs later on. And an advantage of this is that there's no dust or blast gases produced.
So what bioleaching is a subsurface extraction method. And what it does is that it's highly selective to the actual mineral that we're using, and the biology is actually selected according to the mineral. So these exist naturally in nature, and what we do is we either bioengineer or we tailor the biology so that it can effectively metabolize the minerals that we're using. Now, when mixed with water and oxygen, it produces an acidic solution that acts as a great leachate solution for our mineralogy. So the lower the pH, the higher the metallic concentration within our leachate, and it's been proven for several different metallurgies as well. So with the increased surface area that the self-frag presents us, we can use this as a continuous biomining method, reducing our mineral handling as well, so we don't have to actually transport all our material from subsurface to the surface. It's environmentally friendlier with 30 times less SO4 and CO2 production, 5 times less water usage, and 5 times less energy usage as well based on existing bioleach solutions, or systems, sorry. It's 5 times faster than chemical leaching based on the synergistic effects of the bacteria, 50 to 75% lower operating cost, and 80-90% recovery as well in a 101-day cycle. So I wanted to highlight that it is a closed loop system, and it is something that we could kind of create a bit of a pseudo-reactor underground, which keeps the temperature high, which helps for our reactivity, and it also allows us to control our O2 injection or water usage through the system with very little makeup with SO4 or sulfuric acid or the water makeup as well. So I highlighted here the long hole mining method at 100% productivity, which is the existing, the 3 times as if you were to transport just 3 times the material that way, and then also our bioleaching method at 150% of the productivity based on the assumption that our drilling time remains the same, you have the same time for blast and self-frag, or self-frag, pardon me, as an alternative, and also the same time for either using the backfill or to actually use the bioleaching method. So that gives us 150% production because we've effectively cut out our mucking time. So to summarize now our northern advantages, there's no additional development outside of what has already been established. We've reduced the demand for heavier mobile equipment, either whether fuel or battery, which also takes care of the reduced maintenance. Reduced power, ventilation, and cooling requirements, fully automated, synergistic with other technologies if we decide to add on, social accountability, superior environmental and health performance, and improved economic feasibility. Thank you guys so much for this.
Given sort of nickel, copper, platinum, palladium, gold,
Yep.
silver, and cobalt, does the method work across that spectrum of metals, or are you being selective and just choosing 1 or 2?
Yes. So the difference with self-frag is that it doesn't actually depend on the metal per se, because it still has that potential difference, right? Any metal is going to be more conductive than the rock mass that's hosting it.
Did you do any geotechnical evaluation of the impact of no backfill at these kind of depths? Because your proposal implied that there would be no backfill.
Yes, so because we're leaving the ore body in the stope, it would be minimal backfill, if it at all was required.
I noticed that in your biosolution in comparison to regular mining methods, you had substantially higher revenue. Why would you assume that? I would expect you'd get lower recoveries.
We actually assumed, I think it was a 90% recovery rate based on the long hole method and the 3 times mucking rate, and we only assumed an 80% recovery for our bioleaching, and it was still more profitable.
Okay, thanks guys.
Thank you guys.
Thank you.
So the third place winner is Team 2, Better Built Belts, Samuel Grant and James Fortune.
Second place, lasting impact, Shivam Sharma, and we particularly thought that this was an interesting and simple solution that could be implemented reasonably quickly, so well done.
Without further ado, my pleasure to announce the first place winner, which is Team 3 Northern Mined Operations, Anthony, Michael, and Liam.
Before we ask the teams to step forward and receive their prizes, let's find out who gets the extra $5,000 based on winning the audience vote. So, should be a drum roll or something happen here. Team 3, Northern Mined Operations, well done. Students, please come up on stage to receive your awards. Well done. Dragons present each of you your award.
Excellent. So first off, we just want to thank the organizing committee here. Obviously, there's a lot that goes into these types of competitions. It's very important to recognize the need for innovation in mining. And as we take steps forward, right, we innovate, we develop these industries, and that's what keeps them successful. That's what keeps them going. And so it's important as well that we give the students these opportunities, and we'd like to thank you guys so much for giving us this opportunity to come out and speak in front of you today. Thank you so much to the judges as well. And thank you also to the mentors and the people that take time to help us develop these ideas, to help us, educate us, to help us move forward, because then eventually we step into their footsteps and we move forward in the industry as well. So thank you so much for everyone who helped us. Thank you so much to everyone who came out today, and good luck in the mining industry. Thanks, guys.
I want to thank the boys back home at Tahoe that were cheering me on. Didn't get the first place, but hey, we'll bring it home next year.
Oh, you have to graduate next year. You won't be eligible.
And so we'd like to thank everyone for showing up today, the Dragons for taking time out of their busy schedules, and the mentors that we had also along the way to help assist us in putting together our presentation. I'd like to thank the other teams for showing up and letting everyone know kind of what the future of mining holds for everyone. And thanks a lot.